UK, and their campus in Singapore, and I work at both places in UK as well as in Singapore. This project was carried out in Singapore. Okay. Okay. This is the title of the project is Energy Management System for Smart Home using Internet of Things and Multi-Agent System. There are few intelligent techniques. One of them is Internet of Things, another one is a multi-agent system, and together with machine learning techniques. The purpose or objective of this project is to design and develop an energy management system for smart home, and three things. One is Internet of Things, I mean IoT sensors to collect the data from various devices from the home, and the multi-agent system is a agent system. I will explain what is multi-agent system in few words later. That can do independent or a localized control, and at the same time they can provide a channel for communication among the devices. And we have used several intelligent technique and several optimization algorithm to enhance the function of energy management system. Energy management system is the heart of the power system. The power system can be at a home level or a microgrid level or smart grid level or a bigger power system. There should be a heart. I can compare the power system as a human body, living animals. Whether it's a big elephant or a small rat, there's a heart. Similar energy management system. There should be an energy management system for all the power system. And similar, my energy management system, today I'm going to focus is for homes. Smart home, Singapore is one of the leading country work toward to become a smart nation. Smart nation has several aspects. You can read it if you want to know about smart cities or smart nations. And the main part of the smart nation is a smart grid. Okay, the smart grid is nothing more than is the modern grid. Okay, and the basic elements of a smart grid is a smart home. The smart home, basically there should be a multi-objective. We have to minimize the electricity bill without affecting our comfort level, and we have to integrate every devices, all the electrical devices. Somehow we have to digitalize the control and management of all the devices. Then electricity market, and people have already talked about this one. World is changing. All the power system operation is going to be based on the electricity market. The price is going to change every hour or every half an hour. In Singapore, the part of the customers, they are getting energy from a contestable market, and another part they are getting non-contestable customers. And the contestable customers, the price is changing every half an hour. Every half an hour is a different price. Then based on the price, there can be the demand side management technique, load shifting and other kind of a technique can play a major role when the price changes with the time. Therefore, as a home electricity users, we can play with the electricity price. And the multi-agent system is the technique comes from a computer science or a computer engineering background. We are trying to use this technique for this is one of the best technique for implementing the smart grid. How we are imagining the smart grid and the characteristic of the multi-agent system is exactly matching. It can provide a communication channel, and it can provide a localized decision-making capabilities, and they can communicate each other. If we model the devices and apparatus using an agent, then easily they can communicate, and they can take many decisions, localized and centralized decisions. For example, the Pine from Texas A&M abstract, I hope you are using a P2P point-to-point communication. This is one of the techniques you can, I hope you are already doing something, but this is one of the techniques you can implement. Similar, the MIT project, and you face some challenges for decentralization and localized decision making. If you implement a application layer using a multi-agent system, it can support. This is one of the technique, is promising technique. That's why I told, in the simple words, how we are imagining the smart grid and how we are, how the characteristic of the multi-agent system are matching each other. It's one of the promising technique. We use this one for our home energy management system. And there's a computational IEEE standard to implement this multi-agent system. We use a FIFA standard. And Internet of Things, we basically use to collect the data from the devices. And we have placed IoT sensors in our smart home. And machine learning technique, there are many techniques, and we have tried some of the techniques, and it is providing a promising results. The challenge is we need to have a lot of data. Therefore, we have to wait. We have waited a few years to collect the data. Then, using the data, we have used these techniques, and we have analyzed and we have implemented for our smart home. And basically, if you see a smart home energy management system, major element we can see from the supply side and the demand side and some application sides. And we have published few papers, and if you are interested, you can note down and you can read it more. And that's one of the theses, also PhD thesis. And functions, I mean, similar. This is the energy management system, heart of the power system, heart of the home energy management system. We have addressed several functions of the energy management system, such as supply side management, demand side management, power notification system, power forecasting and clustering, and power consumption and clustering, and energy test system as well. And how we propose our multi-agent system. The agent can be designed. I mean, they can communicate each other, and we can design at any level. One solar panel can be considered as an agent, or one converter can be considered as an agent, or electrical vehicle can be considered as an agent. It's a different, when we design multi-agent system, people can use a different approach to design. This is the way we have designed our multi-agent system. And the main part of the multi-agent system, they can communicate each other. The communications, we try to implement the communications with our knowledge, but in the ideal multi-agent system, they can decide whom to communicate. It's not possible immediately. This project has to evolve at a several stages, then only the real multi-agent system concept will work out. And we use a FIFA standard to do the communications among the agents. And from the supply side, we consider solar panel, battery, and electrical vehicle, at the same time, the power from the main grid. Then the demand side, we consider several devices, the typical home devices. And initially, we use just a simple flow chart for an algorithm. Based on the simple flow chart, we have developed our rules for home energy management. Then the machine learning technique is a part of the agent. They can learn itself. I mean, they can learn and they can develop. The rules can become better and better when they perform in the real grid. And demand side management, as I told, we consider hourly the price changes, but that is still is not implemented in the many countries or many states. But in the future, the price is going to vary with the time. When it's with the time, then the demand side management can play a major role to reduce your electricity bill. But in our studies, we considered prices varying with time. And notification system, yes, we don't want to affect the comfort level of the customers or residents, but we want to notify, yeah, you are using high power, or you are using a low power, or you are using average power similar to other neighbors, something like that. We want to notify. Therefore, we classified the power consumption into cluster using machine learning algorithms, and the power notification system has been implemented. And there are several techniques and a lot of machine learning algorithms. And this is it's not a one-person project, this is a team project. And if you are interested, you can read this thesis. So I will give the thesis title, and you can read and you can study a lot of case studies and the results from the thesis. And another one is the forecasting, because when the market play a major role, the price is going to change. But price is going to change how the customers, we had to plan ahead. Therefore, we had to have a price forecasting also itself in our home or a bigger scale in the apartments. We had to have our own price forecasting model. Then only we can forecast our planning. And we had implemented that one, and we have done, and some price forecasting clustering results has been presented. And most of the technique, we use several techniques, mainly for clustering we use KNN algorithms. And test system also is the last function we have implemented, and we have published at Internet of Things journal. And this is the PhD student's thesis. You can note down this version, and you can find out online version of thesis, and you can read further about his studies. And we have really implemented this one in one of the home in Singapore, and we have used a few houses and implemented a lot of sensors for all the plug points and all the apparatus. We have collected for 2 years data, and we have analyzed, and then we propose our solutions and implemented, and we got the results as well. And the results showing is enhancing the performance and while reducing the electricity price and without affecting the comfort level, is providing a promising results. So one home as an example I have provided how we have implemented. And the real communication happening in our multi-end system. And in conclusions, yes, our smart home energy management system, we have used several machine learning techniques together with the multi-end system platform and Internet of Things sensors. And machine learning can enhance the performance of the functions, energy management system functions. At the same time, multi-agent system can provide a plug-and-play ability, and any device can be plug-and-play at any time. The multi-agent system itself will recognize the devices on, off, and so on. Yeah, that's all my project. If you have any question. Yeah, there's a acknowledgement. This is my PhD students. He's graduated and currently working in HP Singapore, and I thank that research team as well. Yeah.
Thank you for the talk. You mentioned the power notification system was implemented.
Yeah.
I just have 2 questions for that. One is, was there any privacy issue where people feeling uncomfortable that you could see their energy use? And the second one is, how did they react to what they saw? Like if they're using a lot of energy, did they reduce it?
You're highlighting the major problem is privacy issues, because this is our own. I mean, this notification is only for us. Okay, this notification only our mobile application is not implemented yet in a mobile application, but our plan, the home users and the home energy management, we can see, okay, we are using a high power or low power or medium power compared to the neighbors. But it is a biggest challenge, and especially the Singapore, the data protection act is very strong, and this is a big challenge. Yeah. I don't have a solution for that. Yeah.
Did I get it right? You get on distribution grid level and half-hourly price signal from the market. Is this the market configuration in Singapore, or by half an hour? Or?
Yes, in Singapore there are two types of customers. One is contestable customers and non-contestable customers. Non-contestable is similar to the monthly bill. They can know only the monthly bill. They don't have a ability to control. But contestable customers, they are playing in a market, and they can bid and they can get the energy price, especially the biggest industries and the customers, they are playing, yeah. Yes.
Two questions. One is, do the agents behave strategically? And then my second question is, if you had a final result, any numerical results on the percent savings or line of savings?
Yeah, agent behaves strategically because we implemented the communication. The agent behave as we planned. But ideal agents, no, they had to behave themselves. They had to, yeah. At current versions, yes, it's strategically, and we implemented our communication. Okay. The second question.
Did you have any numerical results about percent savings?
Yes.
Just a high level.
I think I haven't, because this is a whole thesis, I cut and paste. I missed that percentage. There's some percentage is a good percentage implement, because when we try different algorithms, because this agent, yes, they can help somewhat, but Internet of Things just a collection of data, but actual improvement together with machine learning, together with multi-agent system. When we try different algorithm, we are getting a better or different results. We can choose the best one. Yeah.
Any other